This example will show you how to test the claim of whether or not there is in fact a linear correlation. So we're going to test the claim that there's a linear correlation between the average temperature versus the gas consumed in a house that has just had insulation. We're going to test this at the 0.05 level of significance. Now the first step of every hypothesis test is to state the random variables. And we've actually already done that, but let's do it again. So we have the average temperature, which is what we're going to call x, and the gas consumption, which is y. So remember, x is what we're using for a predictor variable, y is our response variable. Your next step is, of course, stating the hypotheses. In this case, there are two of them. There's HO, which is rho equals 0. This means there is no correlation. And HA is that rho is not equal to 0. That means there is a correlation. All this problem asks us to do is say whether or not there was a correlation, so that's why it's just not equal to. If it asked us for a positive correlation, then it'd be greater than. If it asked for a negative correlation, it would be less than. Our alpha level is 0.05. The next step of every hypothesis test is to state and check the assumptions. So we have a random sample of 18 pairs of average outsourced temperature and gas consumption was taken. In the example in 10.1.1, it states that the data was collected from a random days, so that is satisfied. Number 2 says for every value of the outside temperature, the gas consumed is normally distributed. So the way we tell this is we look at the scatter plot and see if it looks linear, and in the one in example 10.1.1 did look linear. And we look at the residual plot and we see if it looks random. And the one from example 10.1.3 did look random. So this assumption is in fact checked. The next step is to actually do the test statistic and the sample statistic and the p-value. So what we're going to do is we're going to actually create the R command. So of course the first thing to always do in R is to type in your data set. So our data set is gas is the data set. We're going to read in a CSV, and here is the data where the file is. It's always a good idea to look at the heading of it so you can see kind of the structure of the data. So we see that we have temperature as one variable and gas consumed as another, and look to see what the capitalization and the actual names of the variables are. And now we're just going to do t.test, I'm sorry, not t.test because we're doing correlation, so it's core.test, and then you're going to put in your variables. So gas was our data set, and my first variable is temperature, and then we're going to do comma, and so you always put the independent in first and then dependent, and that one is gas consumed. Now, because the alternative was not equal to, we don't have to worry about putting alternative equals anything. It's just going to assume that. You hit enter, and there's your information. So we look at this and we see that we're doing our data is between the two gas temperature and the gas consumed. There's our t value, and there's our p value. And if you didn't already have the correlation, there's the correlation right here. There is a confidence interval, but we're not going to deal with that in this course. All right, so we're going to go ahead and type that into our data set, into our step 4. So again, we copied and pasted this in, and copied and pasted in the core.test, and here's our output. So the sample statistic is R equals this R value right here. The test statistic is T, which is right up here. Then the p-value, which is based on the degrees of freedom, is right there. So now we can get to our conclusion. So looking at this conclusion, we notice that our p-value is much, much less than 0.05. So we will, in fact, reject HO. And that means there is enough evidence to show that there is a correlation between outside average temperature and the amount of gas consumed.